So our next property we're considering is x to the fourth over x to the fourth. So if I have 4 x's being multiplied in the numerator, and I'm dividing 4 x's in the denominator, well, one set of x's divides out, and another set of x's divide out, and another set of x's divide out, and then another set of x's divide out, and I have nothing left. So when I have x divided by x, that just gets me 1. So everything divided out, and I just get 1. That's interesting. But what if I use the quotient property, where I take the exponent in the top, 4, minus the exponent in the bottom, 4, that gets me x to the 0. Well, which one of these is correct? Is it 1 or is it x to the 0? Well, I submit that these two are equal and that they're the same thing. So even though we looked like we were just talking about exponents that were the same on the top and the bottom, we really were talking about a 0 exponent. So this is a new rule. It's called the 0 exponent property. If x is any real number than the other than 0, then x to the 0 is equal to 1. For example, what's 7 to the 0? That's 1. What's x to the 0? 1. How about 24 to the 0? Well, that's 1. How about 6 to the 0? That's 1 plus 6 to the 1. 6 to the 1 is 6, so this adds to 7. Okay, so that was x to the 1 property and x to the 0. How about 3x to the 5th, y squared, all quantity raised to the 0? Well, the whole thing is just 1. A lot of students have a hard time understanding why the heck x to the 0 is 1. So let's talk about this is not a proof by any means, but it's just kind of showing you where this is going. If I have 2 to the 1, that's 2. If I have 2 squared, that's 4. If I have 2 cubed, that's 8. If I keep going, 2 to the 4th, that's 16. Notice how every time we're timesing by 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. The next one will be 32. Okay? This is exponential growth here. So what if I went the opposite way? What if I did 2 to the 0, and then I have 2 to the 1, 2 to the negative 1, and 2 to the negative 2, and 2 to the negative 3. Now we already said 2 to the negative 1, that's 1 over 2 by the rule. 2 to the negative 2, that's 1 over 2 squared, which is 4. And 2 to the negative 3, again, because of the negative exponent rule, that's 1 over. 2 times 2 times 2 is 8. Notice if we kept going this way, it's 1/8 times 2 is a fourth. If I double that, double a fourth, it's a half. So if I continue this pattern of doubling, what's 1/2 times 2? Well, 1/2 times 2 is 1. And what's 1 times 2? 2. Does it still work? Yes. Or if I go backwards, you can do it backwards too. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1, and so therefore it does work, okay? And then 1 divided by 2 is a half. A half divided by 2 is a fourth, and then a fourth divided by 2 is an eighth. So all of these rules, the negative exponents and the positive exponents and the 0 exponents, all kind of work together as a pattern of every time you're doing this, you're multiplying it by 2. All right, our last type of new property here, when we have a quotient, x divided by y, and then we're raising that whole thing to an exponent. So if we have x over y squared, that means x over y, the whole parentheses x over y, times x over y. So we have x times x is x squared in the top, y times y is y squared in the bottom. So an easy way to do that is just to take the 2 and raise it to the base in the numerator and the base in the denominator. So this is more distributive property, that we call this the expanded distributive property of exponents. So if we have a and b are two real numbers, b can't be 0 because we're not allowed to divide by 0, and r is an integer, then this r exponent can be applied to both the numerator bases and the denominator bases. So for our example, we have x over 5 squared. So that's like x squared over 5 squared. The squared goes to both bases in the numerator and denominator. So if I reduce 5 squared, that's 25. Our next example, we have 2 cubed in the top and a cubed in the bottom. Now 2 cubed can reduce to 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. 8 over a cubed. And our next one, we have 3 cubed in the top and 4 cubed in the bottom. So that gets you 27 over 64, which doesn't reduce, and that's the end of that problem. Now, in the next little spot here is a summary of properties. I've just put all of the properties that you learned today in one spot so that in case you need them when you're doing homework or anything, they're all here. The a to the 1 is just a. That one we didn't really talk about too much, but anything to the 1 is just itself. Anything to the 0 is 1. If you have 2 bases and 2 exponents, that's when you add. Whereas if you have 1 base and 2 exponents with the power property, you multiply. The distributive property, if you have a times b inside the parentheses, all raised to the r, every base inside gets the r exponent. The negative exponent property says a to the negative r is 1 over a to the r, or 1 over a all raised to the r, either way. The quotient property says if you have 2 bases and 2 exponents and you're dividing, you subtract the exponents. That's kind of similar but opposite of the product rule, the product and the quotient. If you multiply, you add the exponents. If you divide, you subtract the exponents. And then the distributive property, the expanded distributive property, that's very similar to the distributive property where any base in the numerator or denominator inside the parentheses gets the exponent on the outside of the parentheses. So the next thing we're going to do is we're going to mix up these problems, and I'm not going to tell you, oh, use the negative exponent rule. We're just going to have you a bunch of problems and you have to work them out. So you can use any of the exponent properties that I summarized on the page before that we explained in any order, since they're all part of the E step in Pemdas. Do you remember the Pemdas? And I usually write Pemdas this way. P-E-M-D-A-N-S. But because all of the rules I just talked to you all land within that E step, it doesn't really matter what order you use them in, as long as you use them correctly, you can use them in any order. But I find that students make a lot of mistakes when I just let them do whatever order they want. So I found that if you do it in this order that I give you, that you make the least amount of mistakes. So step 1, get rid of the parentheses by using the distributive exponent rules. So if there's any parentheses you want to distribute the exponents, and get rid of those. Step 2, make all your negative exponents to be positive using the negative exponent rule. I find that students make less mistakes when they were working with only positive exponents than when they're using both negative and positive. So if you just make everyone negative after you get rid of the parentheses, then you can combine exponents with common bases using all the remaining rules, and then make sure that all your answers have only positive exponents. So for our first problem, because we have the parentheses, step 1 says to take the negative 2 and distribute it in to get rid of the parentheses. So that gives me 5 to the negative 2, y to the negative 8. Because I have 2 exponents on the 1 base y, I have to multiply my exponents. So step 1 is done. Step 2, make all negative exponents to be positive exponents. So these 2 exponents, if we talk about our rule with the tenants and the landlord, you're the landlord, all of your tenants are living upstairs and they're not happy about it, so you're going to move tenant 5 to the negative 2, is going to move downstairs, and now he's positive. Y to the negative 8, he's not happy where he's living upstairs, and you're going to move him downstairs. And because everyone's living downstairs and nobody's living upstairs, you have to put a place holding 1 upstairs, basically to let people know that there still is an upstairs, so that you define people to be downstairs, okay? So we have 1 over 5 squared is 25. Y to the 8th. On our next example, step 1, get rid of parentheses. Well, there's no parentheses. Great. Step 2, make all negative exponent's positive. Now both of these are numerators, so you can put them over 1 to remind yourself that they're a numerator. Y to the negative 4 wants to live downstairs, so you make it positive downstairs. Y to the negative 6 already is upstairs. He's not happy about it, so you move it downstairs. And then you put a placeholder 1 there. Step 3 says combine anything with common bases. So we have 2 y's in the bottom. Because they're both on the same level, you're going to add their exponents. 2 bases with 2 exponents, that means add. And you're going to get y to the 10 in the denominator. Are all of my exponents positive? They sure are, so I am done.